Ya, Assalamualaikum, Doktor. My name is Najiha binti Ismadi. My number matric is CE200166. I am from Group 7 and my group members is Alif Fazan and Muhammad Hafizuddin.
Assalamualaikum. My name is Alif Azhan bin Abdul Rahman. My matrix number is CE200182. So I will present about our project. We need to construct a 6-order bandpass filter. So a type of passive RC filter that passes a selected range or band of frequency by connecting or cascading together a single low pass filter circuit with a high pass filter circuit. So we can obtain a band pass filter. So how the vision? So from the signal input, will pass through to the low pass filter. So our circuit is 6 orders. So the low pass filter is we have a 3 filter, and then we will go pass through to the high pass filter. We have 3 also, and it will generate a signal output. So a band pass filter is an electronic device or circuit that allow signal between two specific frequency to pass, but that discriminates the signal at other frequency. Band pass filter. Band pass filter is the filter which have a property of both low pass filter and high pass filter. So there are two type of band pass filter. The first one is a active band pass filter. It is a band pass filter which require an external source of power and employ active components such as transistor and integrated circuits, known as a active band pass filter. So the second one is a passive band pass filter. So the band pass filter which not use external source of power and consists only of passive component such as capacitor, inductors. These are called passive band pass filter. So for the application that we use for the band pass filter, that we in the band pass filter is, oh, it is a first wireless transmitter, and second one is wireless receiver, and the main function in both type are given below. With the given below. So for the example, for the wireless receiver and wireless transmitter, such as a speaker, radio, that they all use a band pass filter. So that's all from me. Thank you.
Today, I will discuss about importance of active filter in electronic system in relation to the current technology trend. Okay, the newer technologies that can more efficiently eliminate harmonics are active power filters, higher order harmonics as well as lower order harmonics in the power supply are filtered out using active power filters. The propagation of electromagnetic radiation is where displacement current is important. EM is that radio wave and other types of radiation can travel into vacuum-sealed empty space. Therefore, it is clear that a moving shifting magnetic field was always connected with a changing fluctuating electric field. For the advantage of active filter, there are 6. First, these filters are more responsible than passive filters. No loading problem. Active filter using OPM does not load the input load. It does not exhibit any insertion loss. It also allows for isolation control of input and output impedance, and the last, the component used in the active filter is the smallest size as compared to passive filter. Okay, there are three technology, the current technology trend. First, communication system. Okay, first technology is communication system to reduce noise, isolate a signal from many channels and boost the unique message signal from a modulated signal. And active filter are used in communication system by instrumentation system designers to choose the necessary frequency equipment and eliminate the unwanted ones. To transmit various frequency to different speakers, engineers use an analog filter in audio system. For the example, the music industry needs recording and playback apps to control the frequency components. And the second is electronic filters that use active components such as amplifier are known as an active filter. They don't have any attenuation in their output when compared to the input voltage. Amplifiers are typically operational amplifiers that provide feedback from the output to the input. This in turn results in for any signal frequency stability is guaranteed and a large range of frequency response and time domain behavior is available. And the last, the active filters are used in biomedical instruments to link psychological sensors to diagnostic tools and data logic. Okay, there is for a manual calculation. Okay, for the manual calculation is to find our group is given the mid gain 80 dB and the low cut of frequency 2 kHz. High cut of frequency is 50 kHz. And to find the value of capacitance, we use the formula low cut use formula frequency to find the frequency, which is 1 divide by 2 pi multiple R multiple C. So first OPM1 we assume that R1 equal to R2 50 kilo ohm. We get the answer is 5.305 nanofarad. For OPM2 we assume R3 equal to R4 is 25 kilo ohm and we get the answer 3.183 nanofarad. OPM3 we assume the R3 equal to R6 which is 30 kilo ohm and we get the answer 2.658 nanofarad. OPM4 we assume R4 equal to R5 is 40 kilo ohm and we get the answer 0.08 nanofarad. OPM5 we assume 50 kilo ohm and we get the answer 0.064 nanofarad. And last, the OPM6 if we assume to 100 kilo ohm and we get the capacitance is 0.032 nanofarad. Okay, this is for low pass filter. We assume that RA1 and RA2 is equal to 1 kilo ohm. And to find the value of RF1, RF2 and RF3, we use the formula RA multiple gain 1 minus 1. And for the RF1 we get the answer 1.48 kilo ohm, RF2 586 ohm and RF3 is 68 ohm. Okay, for high pass filter, we assume that RA is 500 ohm and we get this answer. Okay, for the total gain, to find the total gain, we multiply all the gain and we get the answer 17.67. Okay, and last, to find the value of RA, we use the formula gain equal to 1 plus RF equal RF divided by RA, and we get the RA is 6.417 milliohm. For the band pass frequency response, we use the formula frequencies to find the F center. The formula is F2 multiple FH and we square root and we get the answer 10 kilohertz. And to find the value of bandwidth, frequency high minus frequency low, and we get the answer is 48 kilo. That's all from me. Thank you.
My name is Muhammad Abzuddin Rahman. My metric number is DE200122. Today I would like to present about multi-sim, my project. So this is our circuit. So as we can see, this is our circuit. So firstly, I want to tell this is a high pass filter because we see the capacitor first and then we see the resistor next. So for the port 5-6, this a low pass because we see the resistor first and then the capacitor. So next we go to the value of capacitor. For C1 and C2, the capacitor is 5.305 nanofarad. For C3 and C4, the value is 3.183 nanofarad. So for C5 and C6, the value is 2.653 nanofarad. So next we go to the C8 and C9. Okay, the value for C8 and C7 and C8, the value is 0.08 nanofarad. For C9 and C10, the value is 0.064 nanofarad. For C11 and C12, the value is 0.03232 nanofarad. So there's a value for the capacitor and resistor. So next we run the circuit. Okay, so when we run the circuit, we go to the board plotter. So we can see this is our graph. So next we just set for 2 kilos first. The value is for dB is 49.262 dB. Next we go to the frequency center. There's a 10 kilohertz. So for frequency center, the dB is 50.251 dB. So next we go to the frequency height. The frequency height is 50 kilohertz. So as we can see, for dB is 46.472 dB. So I think that's all for me. Thank you.